This is our Algebra 2, 3 of 3, section 10.1 on midpoint and distance. We're looking at two different formulas today. The first one deals with finding a midpoint. And we're looking at these points on a graph. So if I have a point here and a point there, we want to know what are going to be the coordinates of the point right in the middle so that it's equidistant from both of those endpoints. If the coordinates for this first point we're given are x1, y1, and the coordinates for the second point are x2, y2, then the x value of our midpoint is going to be right in between these two x values. Now, x1 and x2, it doesn't mean we're squaring anything. These are just subscripts. They're just descriptors. This x point is going to be right in the middle, or the average of those two. And the way we average two numbers together is that we add them and divide by 2. So the x value of the midpoint is going to be the first x coordinate plus the second x coordinate divided by 2. And then the y values are actually going to be exactly the same. We want to know what is the y value of this point right in the middle. Well, it's going to be the average of the two y values, so we're also going to add them together and divide by 2. So here is our midpoint formula. It's simply the average of the x and the average of the y. For an example, if I told you point A was located at 3, 9, and point B was located at -5, 1, and asked you to find the midpoint. Well, we could make a quick sketch. Point A, 3, 9, somewhere up here. Point B, -5, 1, somewhere right there. We could then draw in the segment, and the midpoint would be the point that appears to be right in the middle. And our formula means we need to take the average x and the average y. So calculating the midpoint of segment AB, we're going to add the x values together and divide by 2. Then we're going to add the y values together and divide by 2. 3 plus -5 divided by 2 is -1. 9 plus 1 divided by 2 is 5. So I think the coordinates for this point should be -1, 5. My drawing wasn't great. I didn't spend a lot of time in making sure it was really precise. But as I look at the 2 points and I look where I think the midpoint is approximately located, I see that this answer does seem to make sense. It does seem to be feasible. So -1, 5 is our midpoint. Scroll down here, and I'll write down another problem. And I'll pause for a second and give you a chance to try to figure out the coordinates of midpoints of the coordinates for the midpoint of these 2 points. Go ahead and press pause on your screen, do the calculations, and then you can check your work with what I have here. So if I draw the points again, 3, -8, -7, 2. Our midpoint's going to be somewhere right around in there. For our midpoint, add the x's together, divide by 2. Add the y values together and divide by 2. 3 plus -7 divided by 2 is -2. -8 plus 2 divided by 2 is -3. -2, -3 seems like it makes sense. There is our midpoint. The other thing that we're looking at in this section is distance between 2 points on a graph. So if here's one point, there's a second point. We want to know what is the distance in between them. Once again, we're going to use subscripts to define these 2 points. This point is located at x1, y1. This point is located at x2, y2. And again, those little subscripts are just descriptors. We have our first point and second point. Could have been the first point up here, the second point down there. That doesn't really matter. They're just, again, descriptors. And we want to know how long is this distance in between them. Not the midpoint, but what is the distance between them. These 2 points aren't horizontal to each other. They're not vertical. If they were straight horizontal, we could just count directly from side to side. If they're vertical, we could count directly up and down. But since they're diagonal, it makes it a little bit more difficult. So what we're going to do is draw in this horizontal segment, draw in this vertical segment so that they meet. They'll meet at a right angle. And now what we have essentially is a right triangle on the graph. This segment across the bottom goes from this point over to that point. In other words, we just traveled from left to right, from this x value to that x value. So the length of this segment is x2 minus x1. Likewise, this vertical distance starts up at y2 it goes down to the y value of y1, so this length is going to be y2 minus y1. It's a right triangle, and if you think back to right triangles, we can use SOHCAHTOA, but we don't know any angles, we don't know any lengths yet. Or we can use Pythagorean theorem. If we know these two lengths just by subtracting those values, we can then use Pythagorean theorem to find that side. In other words, if I call this d for distance, the leg of x2 minus x1 squared plus the leg of y2 minus y1 squared would be equal to distance squared. And generally when we have formulas, we don't want to know the distance squared, but we want to know the distance. So if we take the square root of both sides of this equation, we would have x2 minus x1 squared plus y2 minus y1 squared is equal to the distance, and that is our distance formula. Basically what you're going to do when you have 2 points is you're going to subtract their x values, square it, subtract the y values, square it, add those two numbers together, and then take the square root of that, and that will give you the distance between the 2 points. For an example, let's say we have point A located at 5, 9. We have point B located at 2, 13. We want to know what is the distance between them. Once again, I could go to the graph, point A, 5, 9, point B, 2, 13, something kind of like this. We want to know what is that length. They are diagonal to each other, so we're going to have to use this distance formula. Distance is the big square root of x minus x squared plus y minus y squared. And we could have done it the other way. Could have taken 2 minus 5 or 13 minus 9. It's not going to matter because 5 minus 2 is 3. 3 squared is 9. If we had gone the other way, it would have been 2 minus 5, which is negative 3, and negative 3 squared is still going to be a positive 9. Likewise, back here, 9 minus 13 is negative 4. Negative 4 squared is positive 16. 9 plus 16 is 25. So the distance is the square root of 25. And in this case, we can actually take the square root of that and get a nice integer answer. The distance between those 2 points is 5 units. So the U stands for units there. All right, here is going to be another point, another problem. You want to find the distance between them. I'll go ahead and write down the problem. And then what I'd like you to do is try to work it out on your own. So go ahead and pause right now. And then when you're ready, you can come back and check your work. You're ready to check the work. Distance equals big square root of, subtract the x values, 2 minus negative 3 squared, subtract the y values, 4 minus 7 squared. If we simplify this, 2 minus negative 3, there were 2 negatives in a row. That really means plus. So 2 plus 3 is 5. 5 squared is 25. 4 minus 7 is negative 3. Negative 3 squared is 9. We add those together, we get square root of 34. Now this time that isn't a perfect square, and that won't break down at all. So we'll say the distance between them is an exact value of square root of 34, and that is approximately 5.83 units. We'll look for the exact and the rounded answer in that one. And this is going to be the last example from these notes. We have these 2 points, and the goal is to find the midpoint and also to find the distance between those 2 points. So at this point, hit pause, copy down the problems, work through the solutions, and see if you can calculate the midpoint and distance. For the distance, I want the answer in simplest radical form, and then a decimal. And when you hit play again, you'll start getting out the answer so you can check your work. Good luck. For the midpoint, we are going to add the x's together. So 2 plus 10 over 2. And we will add the y's together. 8 plus 4 divided by 2. Add and divide, you get 6 for the x value, and you also get 6 for the y value. So the midpoint is 6, 6. For the distance, we're going to subtract the x values, 10 minus 2 squared, and we're going to subtract the y values, 4 minus 8 squared, and then we're going to look to start simplifying all this. 10 minus 2 is 8, 8 squared is 64, 4 minus 8 is negative 4. Negative 4 squared is positive 16. Then we can add those together. 64 plus 16 is 80. And then this is going to need to break down. I know that it's an even number, so at least 2 goes into it. 4 goes into it, which is even bigger. 16 goes into it, which is bigger than that even still. And I'm going to choose to take 16. 16 times 5 is 80, because 16 is the biggest perfect square. The square root of 16 is a plain old regular 4. Square root of 5 is a decimal, so I'll keep it inside of the square root. So our distance is 4 square root of 5. And if we evaluate that on the calculator, that gives us about 8.94 units. So again, here's a question, and the answers are for the midpoint and the distance in between those 2 points.